We're about to do something a little bit crazy. Can everybody handle this? I know it's been a long day, lots of fantastic content, but I want to bring out the esports in everyone here. Sports go sports. We're doing something that I call developer speedrunning. So this is a very, very unique format. This is a very, very different type of content than you're going to be used to. And so I'm going to appreciate all of your support of this fun activity. Yeah. All right, yeah. Come, feel free, take seats, come relax. This is really supposed to be fun. So you've been watching a lot of content over the last day or so that's very prepared. Speakers have been practicing. Speakers have been preparing. This is not practiced. This is intentionally an impromptu challenge. So my name is Fluin. I'm head of developer relations at Axelar. And one of my big missions is this concept of developer speedrunning. And essentially at the heart of it, developer speedrunning tries to take this concept that you have in video games, where a lot of people play video games, right? How many people play video games? Couple people. How many people watch people play video games online? Let's plays, all sorts of speedrunning, all those sorts of things. So this is a thing that keeps getting bigger and bigger. There's events like Summer Games Done Quick or Awesome Games Done Quick, where they're raising millions of dollars for charity just by playing video games in a competitive way. And one of the things that they do as part of speedrunning is they're trying to complete a task, a game, as quickly as possible. And so there's these exhibitions where they actually put people head-to-head against each other. And so we're taking that from the gaming world, and we're bringing it into the software engineering world, which sounds a little bit weird. So the reason we do this, I want to bring the excitement and semi-competition of like esports to developers. But at the same time, this is fundamentally a learning environment, right? I want everyone here to benefit and learn. And by watching these two folks actually try to build something, have a challenge, think on the fly, they're going to be given a challenge. And I'm going to say, I don't know how to do that. Let me think it through. And we're going to be able to learn and collaborate together. And so hopefully here, this is actually a learning environment for everyone here. And hopefully we're inspiring you to be able to do these sorts of things yourself. All right, let's talk about the format. So each contestant has smart contract development tools of their own choice. That might be Hardhat, that might be Remix, that might be public GitHub repositories. Whatever tools they have, that's how they normally develop smart contracts. And we're going to let them use all those tools now. In a moment, I'm going to reveal a challenge that they've never seen before. And effectively, the first one to complete wins. And if we don't actually have time, if we only get halfway through, if no one ever completes the challenge, we'll judge them based on who got further, who made, I don't know, the more impressive proof of concept, whatever. So I'll be commentating, and in a second, we'll actually be putting up their screens so you can see them developing live. But this definitely has an uncertain outcome. We don't actually know. And so we'll see if we get through one challenge, we'll see if we get through two challenges, and we'll go from there. Has anyone tried typing in front of someone else, like at the office? Like someone peeking over your shoulder? That's hard, right? So these two gentlemen have a whole room of people peeking over their shoulder, watching them every typo. And so just know, we are all humans. They are going to make mistakes. This is intentionally designed as a challenge they've never seen before. This is not rehearsed. This is not in practice. This is impromptu. And I want everyone to be supportive. So let's start off with a giant round of applause for our two participants. All right, that was conference talk applause. I want to hear like sports stadium applause. Let's think your favorite sports team. There we go. That is the energy that we are looking for today. All right, so I'm actually going to dive in now to the challenges. So I'll reveal the challenge, and then we'll see if we can get this beautiful split screen setup that we've Medusa'd together here with multiple capture cards, laptops connected, and we'll go from there. Actually, before we do this, let's give the participants a chance to introduce themselves. So on my right here, we have Gerd.
Hey, my name is Gerd. I'm part of the Squid team, and I'm co-founding Squid, and I'm also Solidity engineer from Sydney, Australia.
All right, let's give it up for Gerd. And on my left, we've got Johnson. Do you want to introduce yourself?
Yeah, I'm Johnson, and I'm a contributor to open source projects and a random builder.
So the idea was we brought together two community members. These are people that are part of the Interop community to show off, to explore, to learn, to fail live in front of you. And so we need all of your support. All right, so we're going to go into challenge number one. So I call this challenge breeding NFTs. So if you've ever heard of CryptoKitties, think CryptoKitties. But your challenge is you need to deploy an NFT to at least 2 chains. And then anytime you have 2 NFTs that exist on different chains, they're able to mate with each other and create a brand new NFT. So I'll repeat that one more time. So we're creating these breeding NFTs where an NFT, when combined with another on a different chain, you can think of this as maybe 2 genders coming together to make a baby. Those NFTs can then produce a new NFT.
Interesting.
Does the challenge make sense? So theoretically, you're going to have to deploy a couple NFTs. They're going to need to be able to communicate. And whenever they get a message that says, hey, I'm from this other chain, let's make a baby. Questions?
So do you have to have like 2 NFTs minted? Like you have to have like 2 inputs for the hybrids.
So you need at least 2 NFTs on different chains.
Well, that's understood. But I mean, when you do like a marry up, so you can send a message from one contract to the other. But how do you like? What's the requirement of like merging those 2?
You can merge them however you want. You can combine the names. You can do nothing. It's totally up to you. The idea is just 2 NFTs coming together to create a new NFT.
Okay, cool.
All right. Any questions?
I'll probably ask some questions later.
Yeah. As we said, they're going to fail, and we're all going to help them, right? One more round of applause.
Yeah, I definitely feel. Yeah. So.
All right. So let's go. So what I'm going to do here now is we have this fantastic dual screen setup. Can you see their screens? All right. So let's do a test for the audience here. Whose screen is this? All right. And whose screen is this? Perfect. All right, so let's take a look at what they've got here already. So it looks like Johnson has started pulling out the ERC 721. He's got an example contract here where he's pulling out what does it actually look like to have an ERC 721. And Gerd has already started on the Axelar executable side. So he's combined he's created a contract NFT ERC 721 of Axelar executable.
Like that.
So again, this is just like real development. You can pull code from the internet. You're going to use libraries. You're going to use interfaces, all these sorts of different things. And so right now, Gerd is trying to construct an ERC 721. One of the things that I think any developer who's ever done anything with Interchain knows is there's like 17 gotchas every time before you get something to work. And so we're going to kind of watch them live, and we'll learn from this experience. All right, let's jump back to Johnson here.
Wait, what? Okay. Yeah.
If you can't see the screen, if it's too small for you, Johnson has resorted to ChatGPT or OpenAI ChatGPT, asking how to build an Interchain NFT.
Wait. Okay.
Let's go back to the split screen here. And again, like some NFTs are entire classes where you can mint as many NFTs as you want. You can do that, but really here, we just need at least 2 NFTs. So one on chain A, one on chain B, and those can be any chains. And we can even talk about whether or not that's local or testnet. It doesn't really matter. We're just showcasing the skill set and the challenge here. What are you thinking about, Gerd?
Well, I'm just trying to work out how to hybrid them.
How to what?
How to combine them, or at least in terms of like metadata.
Yeah. Okay, how to combine the ERC 721 with the Axelar executable?
No, that's not the challenge. I mean.
Okay. So both of these contestants, as you implement a new NFT, those NFTs will need to know about the Axelar gateway in order to send a message, assuming they choose to use Axelar, of course.
First, try to ask this, and then try to. What's the rate?
All right, and so Johnson has up the Axelar local dev environment. So if you've never used the Axelar local dev environment, basically what it does is it spins up a local version of 5 different blockchains, all using Ganache from a command line. So you check out the repo, you run npm run start, and then it spins up 5 different blockchains for you, each with their own Ganache, and then it gives you all of the kind of middleware necessary to simulate Axelar transfers across all these different blockchains. So if we take a look at what Johnson is doing here, he's using those EVM examples in the Axelar examples repo. And he's trying out the NFT linker. I think the NFT linker might be more complicated than you need.
Okay, I try to adjust this code.
Okay, you want to use it as a starting point? Absolutely.
Yeah, starting point, I guess.
NFT linking is fundamentally kind of a more complicated concept that has maybe some features that we don't need, like being able to mint cross-chain and burn on one chain. We don't need to burn either of the parents just to make children. This is not like praying mantis contracts.
Also, okay, I see.
So, in essence, maybe start with shipping an NFT.
Okay.
That then you can add in the Axelar executable to, so that it can send and receive messages.
Yes,
would be one option.
Oh. Okay.
Let's check over at the questionable choice that Gerd has made, which is GitHub with light mode on.
Ah, come on, that's a new profile. I just want to hide my real profile.
All right, so Gerd's got the Axelar examples up, same as Johnson. Has anyone seen an example of this concept of breedable NFTs? Is that out there? Has that been done before?
Yes.
And in an interchain mechanism?
Probably not.
Probably not. Okay, so this is a first here. We're building a brand new, never before seen type of NFT. All right. Gerd is deep into the ERC 721 safe mint, which I believe is coming from the Open Zeppelin interface.
Yeah, I'm just trying to.
So if you've never used the Open Zeppelin contracts, they are absolutely amazing. You can basically import ERC 721, ERC 20, and in very, very few lines of code, you can ship an NFT, you can ship an ERC 20 token. All you have to do is basically extend their constructor. I'm very curious. On Gerd's screen, it says 3 authors have created this contract, which is kind of amazing. That he does the work of 3 developers all by himself.
I don't know. Yes, template contract.
So I will recommend, you don't need to take the name and the symbol as constructors. You can just hard code those.
Well, but then I don't know how the name, so.
Yeah, there's lots of things that, in examples like these, you can just hard code, and you don't need to take as constructors. Obviously, more rigorous coding, more production-ready coding will take in all these things as parameters, but that's not actually a requirement.
Wait, how do you?
Name?
Is there any way to read the NFT deployed on the other chain, read the information about it? Because I think it need to be shared information, right?
So the question was, is there any way to read information about an NFT on another chain? And there's not really any way to have that information. All of the interchain communication that I'm aware of, including Axelar, is push. And so what you would have to do is maybe one of the NFTs is able to initiate a breeding. And so it just says, hey, contract ABC, I'm going to call your breed method, and I'm going to pass my payload to you that just says, here's my name. And then the receiving one, NFT is able to just say, OK, I've received a payload. I'm going to mint a new NFT based on that.
So you mint the NFT, but I guess basically there are 2 NFTs, right? We need to check the owner of these 2. I'm just thinking aloud, right?
I wouldn't even worry about the owner if you don't want to, because theoretically, if you have 2 dogs, you have 2 pets, they can breed even if they're not owned by the same owner. It happens.
So even if you are not owner of these 2 NFTs, you can still mate them?
Yep. If anyone calls,
I see.
I would build an NFT that if anyone calls the breed function or the mate function, just mint a new NFT.
Mint a new NFT on a chain that is specified.
Yep. So
okay.
the way that my mental model works about breedable NFTs, and curious about the audience's ideas as well, is that you have an NFT.
What?
It's able to. It has a breed method that takes in some destination NFT. It passes that message cross-chain and calls the breed method on the destination chain. and then it mints a new one if it has a payload.
I see. So you do need to be the owner of one of the NFT.
I do not worry about ownership
I see.
for this example.
Okay. Just
Theoretically, if you wanted crazy bonus points that aren't really relevant here, you could make it so that you had to own the NFT on both chains, kind of like a NFT birth control, but that is not part of our requirements here.
I see.
All right, let's jump back to Gerd. So Gerd's got a constructor that's taking the gateway, or the gateway, as the case might be, and the gas service.
Yeah.
Two NFT.
So why is it complaining? So it says
Mint
it only takes one XP. Okay.
on the
Fuck it.
destination chain.
It's like that.
Address method of sender and don't check.
There's lots of different tools that they can be using right now. They can be using Open Zeppelin contracts like this ERC 721 standard, where, as you can see in his constructor, he basically just calls ERC 721, and he passes in the name of the NFT and a symbol. And then he's also passing in this Axelar executable, so he's calling both constructors on both of the inherited contracts or interfaces.
Yeah, I think that's standard.
Adding a name parameter here, so that you can, when you construct it, you can actually give it your NFT a name, which is not a hard requirement, but welcome.
All contract.
And it's very interesting how each of them kind of chose their starting points. They both got up the call contract code, so they have an example of how one smart contract can call another. They both have up the ERC 721 sample code. So they're both seeing how to combine both of these contracts.
So,
Gerd is already making his code more flexible by throwing in some parameters into the constructor.
No, I just want to make sure I can deploy two contracts. Token ID. Okay, now this one.
Encode the gateway call contract.
Gerd has a mint method that actually takes in a token ID. This is absolutely one way you can do it. We can just hard code and specify that token ID ahead of time. Another option, if folks haven't seen it, is that Open Zeppelin actually has a contract wizard, where if you ask it for an ERC 721 contract, you can check the box that says auto increment, and then it will give you the code that creates a counter and auto increments the token ID of every NFT that you mint. So both of these are just fine ways of doing things.
What should be the
What's failing?
Oh, it's string.
Unexpected.
And Gerd's getting a very weird module error that token.sol can't find token.json. I have no idea what that is.
Good question. There's probably some clutter somewhere. No, this one maybe.
So this is a very standard part of the development loop. Is you write your smart contract code and you hit execute and you see what happens. And then you do it again and again and again until you get what you're expecting.
So,
all right, let's go ahead and check back in on Johnson over here. How's it going, Johnson?
Not very good. I mean, it's like, I'm just thinking, right? It's like, okay, I first get some string over, get some string as the first step. So yeah, finish the string, and then that string would control that'll control like, I guess, yeah. What do I need on the destination chain to verify, or
for the purpose of this exercise, you don't need to verify anything.
I just need to mint.
Just mint a new. I mean, theoretically, the only contracts that are going to exist that are going to try and trigger breeding of these NFTs is your contract. And so for now, don't worry about verification. If you receive a message, if you receive instructions from the source chain to breed, go ahead and do it.
Okay, and then need some randomness.
And so, for example, you just wrote decode to get which two tokens to merge. Don't even worry about that. Just keep it simple.
Okay.
If someone calls execute, if you get that interchain execution, assume that it's a valid breeding event, and just go ahead and mint a new chain, mint a new NFT
weird
then.
shit's going on here.
Okay.
Gerd, how's it going?
There's some.
You got some hard hat shenanigans going on?
Yes.
Token ID.
This one. There's some validation going on in some of the tasks. Okay, now we go.
All right.
Back.
So by commenting out all of his code, it compiled perfectly.
Yeah, no, I'm just all the test scripts. Okay, now we go. Okay, so
I don't know. I mean,
now we can say function.
wait, how do I decode? Wait, what's the way to decode? Actually, yeah, I'm thinking. What's the way to decode?
All right. It looks like Johnson's back at ChatGPT.
Ah, damn shit. Yeah, probably. Oh, decode. Bias.
I'm curious to see if ChatGPT is better at teaching method signatures than just Googling. This looks pretty amazing. How many people have used ChatGPT to build something? Okay. We've got a lot of AI folks over there. I mean, he's done it. He's got an ABI decode method in his execute that takes in 2 integers. But I will say, don't worry about the actual payload. I would say just get an NFT that's capable of minting.
Okay.
Based on because one of the nice things is when you implement that execute method, that's not actually the method that's being called by the Axelar gateway. What's actually happening behind the scenes in a Axelar executable is the gateway is calling an execute method and passing in all of the signatures from the validators. And so what your execute method is doing that you're actually inheriting from the Axelar gateway or the Axelar executable is a verification of those signatures that then if those signatures are valid, it passes and executes the internal function called _execute. And so by the time you've gotten to the _execute, you can actually know for truth that the network has achieved consensus and pass that consensus and execute it on the destination blockchain.
Okay.
Yeah, this is not an easy challenge.
Okay.
And I don't want to stress our friendly participants out, but I believe we have about 10 minutes left.
Well, no, don't worry. That's just
So the clock is ticking, and again, if we don't finish, that's totally fine. That's wonderful. We'll judge them. We'll probably use a round of applause, and we'll see who got further based on the round of applause. So Gerd's got a declaration error. Identifier not found
yeah,
or untrue.
probably misspelling this one. Yeah.
And I'll give you the same advice, Gerd, that don't worry too much about the formality of ensuring that the contracts are owned by the right people.
No, I'm not. But
Or that the methods are being executed. Right? If you have an execute method that is an internal method, that will be enough.
Source address, actually. I don't really use source.
So
somehow
Gerd's got a mint method called from within his execute. And so if a internal or a Axelar network payload is delivered, he'll actually get the source chain and the source address. And then he's going to mint it to that source address. And he's casting the string source address into an address. So you can use it in the mint method.
still complaining because it's core data. Okay.
Wait, what?
See, and now you're getting into some of the worst parts of Solidity, which is what on earth is call data? Call data doesn't allocate any new memory. It uses the memory that was previously allocated for a function call. And so he's having trouble converting from that call data.
Well, here we go. GPT chat.
Are you using Copilot?
Yeah, it's Copilot.
So if we look at our two participants here, Johnson's using ChatGPT AI to code, and Gerd is using Copilot.
It is
so
different. Like
clearly, AI is the future, and all of our jobs are totally at risk.
That's probably not correct.
All right, let's jump back to the side by side.
Let's jump back to the example.
What does this mean?
So are you stuck on the signature of mint and how to get from a string call data
Yeah.
address?
I'm just trying that.
Gerd, would it make it simpler if I said that you can be the owner of all of the newly bred NFTs? You can be the NFT pound, where all of the stray NFTs end up.
Yeah, in fact, it's the same message that sender it's going to send to the contract, to the gateway, which is not.
Yeah, it would be better to mint it as owned to the source address. But if it saves you time or energy, we can just hard code a specified owner of all the NFTs.
Look, this is.
All right, Johnson, how's it going over here?
The test framework I'm not familiar, and I guess like
gonna do this something else.
I'll just try to test like how.
Are you still in the NFT linker source code as a sample?
Yes, but I'm using the testing framework from the call contract.
Okay.
I'm not sure like this thing like what does it work? What it does like source.
So you're in the JavaScript right now. So you're looking at the JavaScript code that deploys the NFT linker code sample. So it's not just a testing framework. It's also the thing that deploys the contract to the blockchain, to the local blockchain or to the testnet blockchain.
So can I just?
So if you call the method breed from the JavaScript, then you are the thing that is breeding, not an interchain call. But like, I mean, obviously that's a step forward, and then that would let you then figure out, hey, if I can get it to work, this breed method, then I can get that breed method to be executed by an execute method. In an interchain execution.
There's an interchain address, but I need to first deploy it to get address, right? Or where does this address come from? Destination contract address message.
That contract.address, I believe, comes from the contract deployment that happens earlier in the deploy method.
Okay, so if I try.
All right, it looks like Gerd is at the stage where he's now figuring out how do I pay for an interchain call. So when you're using Axelar to send messages across multiple blockchains, there's this really helpful service called Axelar gas service. The Axelar gas service is basically a way for you to pay native tokens, and then those native tokens will be used and converted as necessary to pay for the Axelar consensus, so paying for gas on the Axelar network, and paying for gas on the destination chain. All right, Gerd has a merge NFT option that's encoding the payload.
So this one, and then I can basically do the.
It looks like that merge option is actually what he's going to use to initiate the call out to the second blockchain. And then in his execute method, he's decoding that in order to get back out all the parameters that he passed in.
Linker.
So Johnson's making really good use of the Axelar examples repo, where basically you have this ganache setup of all the different blockchains, and you've got this hard hat setup of these index.js scripts that are responsible for deploying, testing, and executing all of these different options.
Options not defined.
So what Johnson's running into here is the JavaScript for deploying and executing has a lot of functions that we may or may not need in terms of like being able to take extra arguments. So for example, if you're trying out the call contract example in the Axelar examples repo, what you're going to see is that it allows you to actually pass in any message you want, any source chain, any destination, and it will use those to deploy your example code to the right chains. You can see how this would be very valuable as a smart contract developer because, hey, we can't just assume that we're always going from Polygon to Avalanche, right? We want to think through all of the chains that we support and make them dynamic so you could actually pass that on to a more dynamic testing framework.
Option is not defined.
All right, Gerd has the gas. There's a typo in your gas service. I don't know if that's a problem. It's gas service.
No, I was just copy pasting it, or maybe that's just.
It's the not the interface, the name of your variable. Sorry. Yeah. All right, we've got 4 minutes left on the clock. We're going to start a very official timer on my phone that will beep as soon as the time runs out. And the moment that the time runs out, no matter where we are, no matter how close we are, we're going to all stand up and give both of these participants a huge round of applause, but not till the timer goes off.
Destination dot is not defined.
Okay, so this
Johnson continues to fight with JavaScript. One of my friends in blockchain, Patrick Collins, hates JavaScript. And so he would say that the reason for most of the failures is just pure JavaScript. Like Solidity is this pure golden language, and JavaScript is the problem. But he also doesn't use semicolons in his JavaScript, and so I get very confused.
Wait, what?
All right, looks like Gerd is getting very, very close. He's got a merge NFT function that takes the token ID, the destination chain. He's got a bunch of parameters. He's encoding a payload. He's calling contract. One thing I think he might be missing is the paying the gas receiver, but that could go right before a contract call. And he could probably just copy and paste that code from the example here, which is exactly what he's doing.
How did I even wait? Wrong. That's good.
So it's not compiling. There's some
All right, we've got a hard hat compilation error.
gas receiver. Okay, well,
Oh, that's good.
let me.
So you're trying to instantiate Axelar gas service with an address that doesn't exist
Yes.
at that
Should I do it?
place.
I don't think so. I don't think so.
No. It says address source relevant for modifier.
Wait, how did I actually
That's probably the line break.
call contract?
All right, we got 2 minutes left. We're coming down the wire here. We're going to see how far we get.
Wait.
So again, the challenge was to create a pair of breedable NFTs that live on multiple blockchains, are able to communicate, and when one initiates a breeding event with the other one, we mint a new NFT. You can see how this would be universally applicable to every Interchain dApp out there, right?
How is it even possible? Interesting.
Okay, what's going on?
Wait, what does this even mean?
It's not pay, but
Call contract, local. Wait.
All right, so Johnson's actually got automatic token minting implemented. So this is part of that magic of that index.js file, where it actually handles a lot of the execution and setup. So you've got a deploy method, and you've got an execute method. And so what he's got is he's automatically deploying and minting as part of his setup process all the way from index.js. I don't actually know how Gerd is doing the initial mint of the NFTs that he's got here. We've got the old debugging technique of comment everything out until it works, which is a tried and true technique.
So this one, the contract.
All right, we are down to the last minute here, folks. I think this is going to come down to an audience judgment. And so in about 55 seconds, I'm going to tell my phone is going to beep. We're going to tell the participants to stop. We're all going to stand up, give them a round of applause, and then we're going to help pick the winners. So think about what they've accomplished here in terms of what tools they've used, how far they've gotten towards the challenge. Think about style points for how they're using the tools that they've got, how readable their code is, how talented they were at using AI. All these sorts of different things are going to come into the final judgment, but it's up to you. We're just going to do it by round of applause.
Wait, quick question. Actually, I forgot how this chain, destination chain, actually constructed.
How is the designate? How are you constructing the NFT on the designated chain? That is a question for another day. 3, 2, 1. Beep, 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 beep. Let's stand up, stand up.
Okay.
Fantastic job to both of our participants here. All right, so we're going to do applause to figure out who won. All right, let's hear it for, but first, big applause for everyone. Johnson, everybody, applause. Gerd, applause. All right, and now to see who won. Who thinks Johnson won? Okay, yeah. And who thinks Gerd won?
Didn't work.
All right, so by audience consensus, decentralized consensus, thank you. Gerd has won this challenge. Thank you so much for being part of this Interchain Interop Speedrunning, developer speedrunning, this esport that I'm trying to make a thing. And have a fantastic night. I don't actually know. Galen, are you coming back up? See, this is what happens when you, it's called nerd sniping. They're both going to sit here trying to fix this for the next half hour. I'm going to have to cut them off and drag them off stage.
There's a happy hour across the street at Lester Pearl. I don't know if anybody told you all, but I guess we won't be seeing you.
When you give intelligent people a challenge, they're like, oh, now I have to solve this challenge. But we've got to kick everybody off the stage here. Thank you guys again.
All right. Big round of applause. One more big round of applause for speedrunning. That was awesome. That was a lot of fun. So, yes, a few numbers that you need to know. 6:30 is the time until which happy hour is open at Lester Pearl across 26th Street. What else? Oh, 8:30. That's the time in the morning tomorrow when the Biddle Breakfast kicks off right here at Green Spaces. That is investors, ecosystem funds here looking to deploy capital, looking to meet startups. If you are raising capital for your startup, for your project, come through. We'll have some breakfast. What else? Oh, what's the elevation of the city of Denver? Does anybody know? Is it 5,000? It's 5,000 feet? Well, that's another number you need to know, right? For all you flat earthers, okay? Elevation is real, okay? Altitude is real, so don't drink too much tonight. Every beer, drink a glass of water. All right? Everybody have fun, and we'll see you again here tomorrow.